times the word data. Now, can you tell me what's your take on data? Can you explain what is
Sir,
data?
sir, it means information.
No, 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 no. Data is not information, son. Data and
Sir,
information, they are two different things.
a tabular method of collecting some, like in the form of a table or something.
Okay, if it is not in a table, then it's not data?
No, it is also that. Sir, anything on our computer, like wherever we are searching any kind of web address or something else, everything is clustered into data only.
If I write like this, if I write 10, 10, 21, can you see that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What is this to you?
Data.
That's a number, right?
Number.
Data.
Sir, collection of numbers or alphabet, something like that.
Collection of numbers or alphabet.
Yes.
Okay.
Yes,
Okay.
sir.
Let me ask
So
you a question.
information stored in the computer.
The input given to the computer.
That is not computer specific. Data, you can store data in your, like your people used to use phone and address diary. A little one used to carry 20 years back. Nowadays, people store everything in their Android phone now. So I'm talking about 20 years back. If I keep all your names, addresses, and phone numbers in my little diary, what is there in the diary? Is that data, or it is not data because it is not in a computer?
It's data.
Data, sir.
Data, right? So it's not about
Yes.
computer. Okay, that has nothing to do with computer or any particular machine. Data, I just put 10, 10, 21, that's data. But it doesn't mean anything to you, right? Now, I
The systematic
am
collection
processing.
of information.
I'm putting two slashes right there. Okay. Now, what do you see? What does it look like?
So date.
A date,
Date.
isn't it?
Date.
Even then, you really okay. Let's make it. We are not 21 there yet. Let's make it 93. Okay. 10, 10, 93. We don't know whether we'll go there or not. I'm just joking. I'm sure we'll reach there. 10, 10, 93. It is still a data. Okay. It doesn't have any meaning. Now, if I write what did I write on the left side? Date of birth, DOB. Okay.
Yes. Yes, sir.
DOB of Mr. XYZ is 10-10-93. Okay. Does it make any sense to you now?
Yes, sir.
That is information. So when you process data, it becomes information. Another example I'm giving you, at the end of the semester, when your results come out, everybody go to the web and check your result, semester result, right? You get the result in a tabular form. There is whole bunch of basically data there, like which course you have taken, what's your name, your roll number, registration number, and then different courses and their letter grades, right? And then your GPA and all that, right? When we go there and we check, we get to see all of yours data. That is data. Now, if you ask, sir, how many people in our section got above 9? So I have to either manually, check it, process it, and tell you like maybe 5, 6, or I may have a computer program which I'll just run through, and it's going to tell me, okay, the number of 9 pointers in that particular semester. So when we process that data, we get an information like 6 people got above 9 this semester. That is information. Okay. Is this making any
Yes,
sense
sir.
to you?
Yes, sir.
Yes, sir.
I'm just talking about data information. Have you seen a pyramid like this? Right at the bottom is data, and then right over information. And then knowledge. What will be here? Any guess?
Result.
Like from data we get information. When you get information, from information we derive knowledge. And what do we get when we churn our knowledge? Huh?
Facts.
Facts. Facts. No. It's called
Result.
wisdom. Okay. This is the pyramid of data, information, knowledge, and wisdom. Anyway, it has nothing to do with really data structure course, but I just thought that it will be relevant to show you this pyramid. How, we started from raw data, and then we process, we get information, and then through information we derive knowledge, and from knowledge we finally reach wisdom. And very few people actually reach there on the top. Wisdom is not something that comes easily, right? Anyway, this course is about data structure and algorithm. Let me go to data structure part. Basically, what is data structure? As far as if you go to the Wikipedia and all those typical textbooks of computer science, you will see that how data structure is all about how you store data, organize it, and manage it. Basically, managing data means basically how you add, delete, update, and all that stuff, and then you basically efficiently access the data. Okay, that is data structure. Now, why data needs to be structured? I give you one simple example. I don't know how many words are there in English language, or for that matter, even in Bengali or Hindi or any other language. Let's talk about English, probably quite some million number of words are there. Now, they are actually organized in alphabetical order, isn't it? Right? Hello?
Yes, sir.
Okay. Now, if they were not organized in alphabetical manner, would you be able to access any particular word if they were in haphazard order, random order? No, right?
No, sir.
It will be crazy to find a particular word when they're not organized properly. So data, this is one practical example of data needs to be structured, otherwise you won't be able to access it efficiently. Okay. Algorithm, let's come to the algorithm. Okay, what is your take on algorithm? Like you have written some algorithm in the last semester, right? Simple algorithm, like find out the
Yes.
highest number from 3 integers.
Yes,
Or what else did you do in the intro to computing? Some algorithms you have written, can you remember?
For Armstrong number.
Prime number, check the prime
Prime
number.
number,
Angstrom
odd
number.
number,
Odd or even, leap
Odd
year
or
or
even.
not.
Natural
And then
numbers also.
Palindrome.
and then
Fibonacci series.
come up in natural numbers and stuff like that, right?
Perfect number.
Yeah, summation of m number, first n number.
Yeah. Okay, I got that. Now, what do you think about algorithm? What's your take on that? I mean, if I ask you what is algorithm, what will be your answer?
Combination of rules or set of rules.
Combination.
Representation of any problem.
There are rules, definitely.
To solve the problem with data.
Sir, a method which we can implement to solve basic problems.
Yes, sir.
Yes.
Yes, sir.
Method.
Yes, sir. Rules to solve some problem.
Something real life. Okay, can you tell me something real life that is coming very close to algorithm? A clue.
Sir, if we have to eat, then we have to cook. So this is kind of algorithm that we need
Say
to
that
follow.
one more time. Say that one more time.
So
Hello.
like if we have, yeah. Hello.
Yeah, go ahead.
Yes, so like if we are hungry and we need food, so for that we need to cook. So this is kind of algorithm that we have to follow to get our food.
Not really, but it's getting closer. It's something that relates to cooking.
So,
Yeah.
if we have to make tea, then firstly we step by step. Like firstly we take the pan and then the amount of water and then amount of sugar, and these all are specified like how we have to do, like step by step,
Yes, sir.
something like this.
What about a recipe?
Yeah.
In every house, whenever our mom
Yes.
wants something, they need a recipe, right? New dish, right? A recipe comes very close to algorithm. Now, there are basic 5 features of algorithm. Please write it down. Okay. Number 1 is regarding input. Okay. Number 1, input. 0 or more, 0 or more input. There has to be, there could be 0 input or even more than 0, like 1, 2, whatever. Okay. So input could be 0. Output, feature number 2, output, 1 or more output. Means there has to be at least 1 output, maybe more. All right. Definiteness. Definiteness means the third feature, definiteness, means the algorithm will come to an end after finite number of steps. It cannot go on forever. That's definiteness feature. Number 4, it should not be ambiguous. All the instructions in the algorithm, they should be very clear, unambiguous. Number 5, effectiveness means each and every instruction you should be able to carry out with a piece of pen and paper. You don't need any particular device like computer or calculator or something like that. Okay, you don't need any of that. You can easily carry out each and every instruction with every instruction should be so simple that you can carry out with a piece of pen and paper. And then these are the 5 basic features that you will find in most of the textbooks. Then there is one more you please add, which is really important. I always add this. That is, your algorithm should be independent of hardware and software. Your algorithm should be independent of hardware and software. Now, I will start from input, 0 or more input. If you go back to your intro to computing class, can you remember a function that you used which had 0 input?
Yes, sir.
Which function?
A basic printf function. It can be a void function, sir.
No. Printf, you always pass parameters to it.
No, sir. Like if we create a function and the return type of that function can be void, and inside that function we can write a statement of printf. So that will whenever that function will be executed, so this don't require an input.
Something, I'm talking about something that is a library function that you use. Clear screen. Okay.
Yes, sir.
If you use a CLR SCR function, that has no input, right? But it does something for you. It clears the screen. Okay. That is one I can remember. Now, 0 input, output is at least 1 output or more. And then, finite number of steps. That's very easy to understand. And then effectiveness, and then unambiguous. Every instruction should be unambiguous. Like, can you give me one example, like an instruction that is ambiguous? Anybody? Like let's say I am making a cup of tea, and in the recipe, one line says, one step says, add 1 or 2 teaspoons of sugar. That is the example of ambiguous instruction, because it says 1 or 2. You really don't know 1 teaspoon or 2 teaspoon, right? And when you devise an algorithm, it should be it shouldn't be like that. Every instruction should be clear and unambiguous. Okay.
Sir, can we take the example like when an input, suppose there is a string as an input, so we do not know actually what the user will input. It can be of 1 word or 2 words or 3 words, and depending upon that the operations will be performed.
That is about variable input that you are talking about. Okay, there are some functions which take variable input. That is not an instruction really. That is not an example for algorithmic instruction which is ambiguous. Okay. Now, why we study data structure and algorithm together? I give you an example. Let's say you are making a cup of tea for the first time, and I give you the recipe to make a cup of tea, and it's a reasonably good recipe, and then I give you the ingredients for making a cup of coffee. Can you make a cup of tea? Hello?
No, sir.
No, sir.
It is not possible, right?
No, sir.
Then you have the algorithm to make a cup of tea, but you don't have the right kind of ingredients to make the cup of tea. The ingredients you can think of, data. Okay. Now, which means you may have a very efficient algorithm, but if the data structure that does not go along with it, then you don't have a good programming solution. Okay. Have you ever seen this? data structure plus algorithm equals to, what should I write? Data structure plus algorithm equals to program.
Data structure.
Okay. Now, to have a very good, efficient programming solution to devise one, you have to have a proper algorithm and also a data structure that goes along with it. Okay. And another thing we'll be studying a little bit in this course is like, you shouldn't stop at devising an algorithm. Your algorithm should be an efficient one. Why? I give you an example. Let's say I have 5 numbers like 2, 5, 7, 9, 11, right? And I'm keeping it in an array. Okay. Now I'm asking to find out, let's say, number 9. If this number is there, search for number 9 if that number is there or not. Okay. Now, applying a linear search. I'm sure you have done linear search in the last class, right?
Yes, sir.
Yes, sir.
Yes,
So
sir.
what you basically compare with your target. Your target is nothing but your target number 9. 2, you don't find it, there is no match, then you go to the second one, 9 versus 5. This is not 9 either. Then 9 versus 7, and then 9 versus 9. Yes, you found your match. Okay, this is linear search. Okay, and then there is another person who looked at this number. They are in ascending order. He or she is going to apply binary search. This binary search algorithm is nothing but it starts right from the middle. It finds the middle element and and compare this middle element with the target. Okay, 3 things can happen. A match occurs, so you found it, and when there is no match, they are not equal, then 2 things can happen, either less than or greater than, right? So if it is less than, your search will be on the left side of the middle element, right? And if your target is greater than, which is the case in this case, so you start from, you focus on the right hand side, which means you will find next time the middle element between these 2 numbers. Okay, so this will be basically a lot easier. Maybe second or third comparison you will find it, and in this case, you, of course, this is only 5 numbers we have taken. If we take 1000 numbers, you can easily figure out that binary search is much more efficient than linear search, because in linear search, if the number is on the very right side, on the extreme or the end of the list, then you end up making nearly 1000 comparisons, whereas 2 to the power 10 is 1024. You will be maximum comparing 10 times, and definitely within 10 comparisons you will find your target. Okay, so your algorithm, you have a searching algorithm, you have 2 searching algorithms. One is linear, the other one is binary, but binary search is more efficient. That's why the efficiency of the algorithm we'll be studying. And in terms of efficiency will be, what do we look at?